Hello everyone, welcome back. In today's tutorial we'll be talking about recursion. Recursion is never a favourite topic with anyone that's studying computer science. It's quite confusing, but I'll try my best to simplify it for you. So what is recursion? Recursion is the idea that a function can call itself. If we had a function called Bucky, and on screen it printed cout OMG WTF BBQ. Then it called the function again. So we would run main first, which would then run Bucky, but Bucky would say print this and run Bucky. And this function, printing out OMG WTF BBQ, would continue like an endless chain. So then why do we use recursive functions? Firstly, when you build a proper recursive function, you need something called base case. A base case is an ending point for your function. So let's look at an example, how to calculate factorials. So 5 factorial is written as 5 exclamation point and is the same as 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. So a factorial would be any number times all the numbers descending to 1. The value of 5 factorial is 120. The value of 3 factorial would be 6, because 3 times 2 times 1 equals 6. So now we'll build a program to perform this task, and here is where recursion comes in useful. So we'll make a function called factorial finder. Type in int factorial finder. Then it will take a parameter, which is int x. The parameter it takes is what value we want to find the factorial of. For example, if we pass it in 5, it should give 120. In 3, it should be 6, etc. We have to start by building a base case. We need this base case to ensure that the factorial finder function ends. Without a base case, it would just continue endlessly. So if x is equal to 1, then return 1. When you return something, the function ends. To do this, we have to assume other numbers will also be passing in, not just 1. If they pass in numbers like 5, 3 or 20, then you need to return the value of x, which is 5, 3 or 20, then multiply that by factorial finder x minus 1. This calls the same function again, but with a different value. It'll call it with one value less than before. If you pass in 5 to this function, it will call 5 times the 4 factorial. Then it will call 4 factorial 3, 3 factorial 2, then 2 factorial 1. And each time we don't know what the value is. That is until we get to 1. Then we think, oh, we do know the value of that. 1 factorial is 1. Now that it knows this, it will be able to solve the answers to the other values. So if 1 factorial is 1, we can work out 2 factorial would be 2, and 3 would be 6, 4 factorial is 26, and 5 factorial would be 120. But it had to go through a long-winded process to get to 120, i.e. first search through 2 factorial, 3 factorial, etc. until it gets to 1. So this is when recursive function comes in useful, and you use it inside the function itself. But you must always have a base case, which is the ending point which solves the question. Then all the others fall into place, and those questions can also be solved. Otherwise it will run endlessly. So you can see why recursive functions are so confusing but do come in useful. There's some complex technical activity which happens that we do not see, but we put our faith in it and that it will work. There's a lot of theoretical programming which takes place and lots of different errors that can occur with the recursive function. So that is why we looked at the good way and the bad ways to use recursive functions. Recursive functions aren't something that are used a lot in programming, however, it is useful to know how and why it's used. So once again, thank you very much and see you next time.